Okay, so we're ready for part two. Part two says, which gender uses Twitter more? And these are confidence intervals now for our difference in proportions. So a recent random sample, of course I'm underlining that, it's important that it's random, of 200 US females revealed 110 use Twitter regularly. I already know my first proportion. It's going to be 110 out of 200 total. Which when I divide that, I get 0.55. It's about 55% then, or actually exactly 55% of my random sample of US females use Twitter regularly. That's not to say the whole population does, but that's my sample. A separate random sample of 150 US males revealed that 60 use Twitter regularly. So there I have my second proportion, P2 hat. 60 out of 150 is 0.4, so that's 40% of the sample use Twitter regularly. So it says to construct a 95%, there's my confidence level, confidence interval for the true difference in proportions who use Twitter regularly, females minus males. So this question literally tells me which direction to subtract. Obviously in real life, you're probably not going to be told that. You're gonna have to decide which direction to subtract. But again, a lot of times, whichever one we mentioned first, that's the one we write first when we subtract. Okay, so I underlined that in orange because that's gonna be the parameter that I'm gonna write down. So my first step is to state, I'm gonna state the parameter, the statistic, the hypotheses, and the confidence level. So my parameter again is not just P, but it's P1 minus P2. It's the true difference in proportions. And I added in here of females and males just to make it clear that I'm coming from two different populations who use Twitter regularly. And I'm doing females minus males. Okay, so then my statistic, of course, if my parameter is P1 minus P2, my statistic is P1 hat minus P2 hat. The difference in sample proportions, so that is 0.55 minus 0.4 or 0.15. And of course, this is a positive difference this time because the first sample proportion is greater than the second sample proportion. So again, I'm already thinking, well, it looks like there's evidence, or we do have evidence that females use Twitter more regularly, or I'm sorry, I shouldn't say it that way, that more females use Twitter regularly than males, but I don't know if that's actually significant. I'm not asked to run a test to find out if it's significant. I'm asked to estimate the proportion or the difference in proportion, so that's what I'm gonna do. So my confidence level is 95%. Oh, and I said I needed to state the hypotheses. I did not need to state hypotheses because this isn't a hypothesis test. This is just a confidence interval. All right, so then plan. This is, of course, now going to be a 2-sample interval for P1 minus P2. That's my parameter. Check the conditions. They're the same as the last part. They both were stated to be random samples. Check. The samples are independent. Again, the sample sizes are different, so they have to be. And it doesn't say anything that these females and males are in any way connected, so it's pretty safe to assume they're independent. And then my successes and failures have to be greater than or equal to 5. So the number of successes, I'm gonna try to make it really clear where this information is coming from. This is my number of successes for the females, and then this is my number of successes for the males, right? Those numbers are both greater than or equal to 5. If there were 110 females who use Twitter regularly, 200 minus 110 is 90. And then my 150 males minus 60 is going to give me 90 as well. Those numbers are all greater than or equal to 5, so that condition is met. So we're ready to perform the calculations. So we go to StatDesk and we look for proportions with a difference of 2 samples. Okay. All right. So we go to analysis. We go to analysis. Now confidence intervals with proportion to samples. So our confidence level is 0.95. Our first sample size is 200. Our number of successes for the first one was 110. Sample size in the second one is 150. And I believe there were 60 successes, right? 60 males who use Twitter regularly. And then I evaluate. And I make sure to write all of these things down on my paper, of course. So when I evaluate, I'm looking for my confidence interval. It is right here, 95% confidence interval. So I'm gonna write down those 2 values there. And it's safe to round to 3 decimal places whenever I am estimating proportions. Remember, whenever I'm estimating means or standard deviations, then I have kind of different rounding rules. I go one more decimal place than the original data. But proportions, I always go to 3 decimal places. Okay, so again, I wrote down my inputs for StatDisk. My interval then is 0.046, rounding to 3 decimal places, to 0.254. So I'm ready to conclude. And remember, the conclusion is just interpreting that interval. What does that interval actually tell us? I was kind of disappointed on the last test to see a lot of you skip the very last problem because it was just an interpretation of a confidence interval. And you guys know how to do this. I know I saw you do it in other parts of the test. So I think you can do this part now. This is we are 95% confident that the interval from blank to blank, filling in the interval values, captures the true difference. And here I'm going back up to that parameter that I stated at the top, the true difference in proportions of females and males who use Twitter regularly. And I'm letting them know how I subtract it again. Okay. I'm noticing that whenever you guys or I've at least noticed one student, whenever you are constructing this sentence, some students like to say that the true difference will be in this interval. There's 95% confident that the true difference will be within this interval, and that's not the case. Our 95% confidence is about the interval itself, the interval capturing the truth. The truth doesn't change. The true difference exists. It's a certain value. It's not going to change. What can change, depending on the sample data, is the interval, right? The interval is based on the sample data. So we always phrase it exactly like this. Switching it around at all really changes the meaning, and then it's wrong. But looking at that interval, I notice there is evidence that the proportion of females who use Twitter regularly is higher than the proportion of males who do, because the entire interval is above 0, right? So the smallest possible difference is about a 4.6% difference. The largest possible difference that this interval says is a 25% difference. So there definitely seems to be evidence that there is that females truly do use Twitter more than males. And that's how we use confidence intervals to evaluate claims as well. So this last part with the star was not actually asked in the question, but I always want you thinking whenever you look at that confidence interval, what would that really mean if I was trying to test a claim? Okay, that's it for the confidence interval. We're going to move on to section 2 next.